So for today's video, we're going to tackle about solving problems involving parallelogram, trapezoid, and a kite. In this video lesson, we're going to define and illustrate quadrilaterals. Next is illustrate different kinds of quadrilaterals and its properties. And the last one, solve problems involving parallelogram, trapezoid, and a kite in a real-life situation. Quadrilateral is a closed plane figure consisting of 4 line segments or sides. It has also 4 vertices, and the sum of the measures of 4 angles is always equal to 360 degrees. These are the examples of quadrilaterals in real life. So we have the envelope, the shape of the pool, kite, table, money, and a door. Can you see a quadrilateral objects in your home? Okay, that's great. Let us now proceed to the following quadrilaterals. We have a parallelogram. Do you still remember the definition of a parallelogram? Okay, so a parallelogram has 2 pairs of opposite sides which are parallel. When we say parallel, 2 lines that did not intersect to each other. Now, let us proceed to its properties. The first one is, any 2 opposite sides are congruent as indicated in the given figure. Next, any 2 opposite angles are congruent, as you can see in the symbol in the given figure, which indicates that the 2 opposite angles are congruent. Third, any 2 consecutive angles are supplementary. So when we say supplementary, if we are going to add the measure of the 2 consecutive angles, that is equal to 180 degrees. Next, diagonal bisect each other. And lastly, diagonal forms 2 congruent angles. Now, let us proceed to the trapezoid. A trapezoid has 1 pair of opposite sides parallel. Now, let us recall its properties. The median is 1/2 the sum of the length of the bases. Let us now proceed to the isosceles trapezoids. So when we say isosceles trapezoids, it is the 2 non-parallel sides or legs are congruent. Now, let us proceed to its properties. Base angles are congruent, as indicated in the given figure. Next, opposite angles are supplementary. As you can see in the given figure with the same color, if you are going to get the sum of the 2 angles or the 2 opposite angles, that is equal to 180 degrees. Next, diagonals are congruent. Now, let us proceed to kite. The perpendicular bisector of at least 1 diagonal is the other diagonal. Now, in the given figure, you have there diagonal CD, bisect diagonal AB. So, your diagonal AB is now divided into 2 congruent segments. And angle D, since it is bisected by diagonal CD, your angle D is now divided into 2 congruent angles. And your angle C as well is also divided into 2 congruent angles. We also have side AC, which is congruent to side BC, as well as we have side AD congruent to side BD. And the area is half the product of the length of its diagonal. So those were the important concepts and properties that we need to remember, because later on, we will apply that in solving problems. So my dear students, are you guys ready? Okay, let's get started! Example number 1. We have ABCD is a parallelogram. Give the following. Question number 1. the opposite sides that are parallel and congruent. So here, we're going to name those opposite sides that are parallel and congruent. We have side AB is parallel to side BC. And we have side AD is parallel to side BC. And at the same time, we have side AB is congruent to side BC. And side AD is congruent to BC. Question number 2. The opposite angles are congruent. So we have angle A is congruent to angle C. And angle B is congruent to angle D. Let us now move on to number 3. The consecutive and supplementary angles. So when we say consecutive, it is the angle that next to that angle. And supplementary, if we're going to add the measure of the two consecutive angles, that is equal to 180 degrees. So we have the measure of angle A plus the measure of angle B is equal to 180 degrees. And the measure of angle B plus the measure of angle C is equal to 180 degrees also. And the measure of angle C plus the measure of angle D is equal to 180 degrees. And we also have one measure of angle D plus the measure of angle A is also equal to 180 degrees. So they are supplementary angles as well as congruent angles. Next, number 4, the diagonals that bisect each other. So we have two diagonals here in the given figure that meet at point E. So if we're going to consider the side AC, it bisects side BD. So therefore, it will divide it into two equal segments. We have the segment BE is congruent to segment ED, as well as if we're going to consider the side BD, it bisects side AC. Therefore, the two equal segment is segment AE is congruent to segment EC. Number 5, two congruent triangles. If we're going to consider the diagonal BD, it will form two congruent triangles. That is, triangle BCD is congruent to triangle DAB. As well as if we're going to consider the diagonal AC, triangle ADC is congruent to triangle CBA. Example number 2. Quadrilateral LOVE is a parallelogram. Find the length of each side and each angle. We have the condition here if the measure of angle L is equal to x plus 15 degrees and the measure of angle V is equal to 2x plus 5 degrees. What is the measure of angle L? So our first step here is we're going to solve for the x. Always remember that the angle L and the angle O are supplementary. If we are going to add the measure of angle L and angle O, their sum is equal to 180 degrees. So meaning to say, whatever the value of the angle O, that is also the value of angle E. So we have the measure angle L is equal to the measure of angle V. According to the property of a parallelogram, opposite angles are congruent. Now, let us substitute the measure of angle L, that is x plus 15, equals to the measure of angle V, that is 2x plus 15. Now, let us apply the combined like terms. We're going to transpose 2x to left side and 15 to the right side. So, let us simplify. We have x minus 2x is equal to 5 minus 15. What is x minus 2x? Okay, that is negative x. Then 5 minus 15, that is equal to negative. So in order to eliminate the negative sign of the x, we're going to multiply negative 1 to both sides. So our x now is equal to 10. Next, we're going to solve for the measure of angle L since we have the value of x. So measure angle L is equal to the x plus 15. Now, let us substitute the value of x, which is 10. So 10 plus 15, okay, correct, that is 25. So the measure of angle L is equal to 25 degrees. As I said a while ago, the measure of angle L and the measure of angle V are both equal or the same because that opposite angles are congruent. Letter B. If the measure of angle L and the measure of angle V is equal to 25 degrees, what is the measure of angle O and the measure of angle E? First, let us solve for the measure of angle O. Let us remember that the consecutive angles of a parallelogram are supplementary. So the measure of angle L and angle O is equal to 180 degrees or what we call it supplementary angle. So meaning to say that the measure of angle O and angle E is also the same. So we have the measure of angle L plus the measure of angle O, which is equal to 180 degrees. Next, let us substitute the measure of angle L, which is 25 degrees. So we are looking for the measure of angle O. So we have 25 degrees plus the measure of angle O is equal to 180 degrees. So if we're going to look or to get the value of or the measure of angle O, let us apply the subtraction property of equality, wherein we're going to subtract the 25 degrees both sides. So that is 25 degrees minus 25 degrees, that is 0, and it will refrain measure angle O. And 180 degrees minus 25 degrees, that is equal to 155 degrees. Since the measure of angle O is equal to the measure of angle E, therefore the measure of angle E is equal to 155 degrees also. Next, letter C. What is the measure of angle LEZ? So measure LEZ and the measure of LEV form a linear pair, meaning to say two angles are adjacent and they form a straight line. Therefore, their sum is 180 degrees. So, to solve the value of angle LEZ, we're going to subtract the angle LEV from 180 degrees. So 180 degrees minus the measure of angle LEV, which is 155 degrees. So 180 degrees minus 155 degrees, that is equal to 25 degrees. Now, our measure for the LEZ is equal to 25 degrees. Did you get it, guys? Okay, very good. Example number 3. Two opposite angles of a parallelogram have measures 3x minus 40 degrees and 2x plus 10 degrees. Find the value of x, then give the measure of the angles. Let us remember that we're going to apply here the property of a parallelogram where opposite angles are congruent in order to find the value of x. So we have 3x minus 40 is equal to 2x plus 10. Next, Let us combine like terms. Transpose 2x to left side and transpose negative 40 to right side. And same procedure, we're going to change the sign. So that is 3x minus 2x is equal to 10 plus 40. Next, let us simplify. 3x minus 2x, correct, that is x. And then 10 plus 40, okay, correct. So our value of x now is equal to 50. Now, let us substitute the value of x to the original equation. We have 3x minus 40 is equal to 2x plus 10. Then, let us substitute the value of x. So, we have 3 times 50, that is 150. Minus 40, that is 110. So, 2 times 50, that is 100, plus 10, that is equal to 110. So, they are the same. So, the value of x is equal to 50, and each unknown angle measures 110 degrees. Are you all following, guys? Okay, very good. Example number 4. A quadrilateral hoop is a parallelogram. We have the condition here. If the side HO is equal to 3y plus 3 and the side EP is equal to y plus 13, how long is the side of the HP? Take note that the opposite sides of a parallelogram are congruent. So, HO is equal to side PE. Now, let us substitute the value of the side HO and side PE. We have 3y plus 3 is equal to y plus 13. Next, combine similar terms. Transpose y to left side and transpose 3 to the right side. We have 3y minus y is equal to 13 minus 3. So, what is 3y minus y? Okay, correct. That is 2y. And then 13 minus 3 equals to 10. Next is let us divide both sides by 2. So, cancel, bring down y. 10 divided by 2, that is equal to 5. So, the value of our y here is equal to 5. In order to solve for the side EP, substitute the value of y. Using the original formula or the equation of the side EP, which is y plus 13, let us substitute the value of y, which is 5. So that is 5 plus 13 is equal to 18. Correct. So the measure or the side EP is equal to 18. Since the side HO is equal to side EP, therefore, the side HO is equal to 18 as well. Did you get it? Okay, very good, guys. Example number 5. Jean purchased a parallelogram sheep farm. She wanted to enclose it with a perimeter fence. How long should the perimeter fence be if the two adjacent sides measures 45 meters and 28 meters respectively? Do you still remember the property of a parallelogram? So, one property of a parallelogram, two opposite sides are congruent. So, meaning to say, if that side has a measure of 45 meters, its opposite sides has the same measure, which is 45 meters as well. And if that is 28 meters, its opposite sides has a value of 28 meters as well. So, if you're going to get the perimeter, you're just going to get the sum of all sides. So, perimeter or P is equal to 28 meters plus 45 meters plus 28 meters plus 45 meters. So, we have 146 meters. So, the perimeter fence should be 146 meters long to enclose the farm. Did you understand? Are you guys following? Okay, very good, guys. Example number 6 about trapezoid. In an isosceles trapezoid ABCD, the measure of angle A is equal to 3x plus 30, and the measure of angle D is equal to x plus 70. Now, let us find the measure of angle A and the measure of angle B. Remember that the base angles of an isosceles trapezoids are congruent. So first step is we're going to solve for the value of x. So we have the measure of angle A is equal to the measure of angle B. Let us now substitute the measure of angle A and the measure of angle D. So the measure of angle A is equal to 3x plus 30, and the measure of angle D, that is x plus 70. Same procedure, combine like terms. Transpose x to the left side and transpose 30 to the right side, and then change their sign. So we have 3x minus x is equal to 70 minus 30. So 3x minus x is equal to 2x, correct? So 70 minus 30, that is equal to 40. So 2x is equal to 40. Next is we're going to divide it both sides by 2. So this will become x. So 40 divided by 2, that is equal to 20. So the value of our x here is equal to 20. Next is solve for the measure of angle A. So the measure of angle A is equal to 3x plus 30, right? So we're going to substitute the value of the x. So that is 3 times 20, that is equal to 60, plus 30, that is equal to 30. So the measure of angle A now is equal to 90. So what do you think is the measure of angle D? Okay, correct. Since the measure of angle A is equal to 90, the measure of the angle D is also 90. Very good, students. Since angle A and angle B are supplementary angles, then measure of angle A plus measure of angle B is equal to 180. So let us substitute the given value of the measure of angle A. So the measure of angle A is equal to 90 plus the measure of angle B is equal to 180. So since we're looking for the measure of angle B, transpose the 90 to the right side. So 180 minus 90, that is 90, correct? So measure of angle B now is equal to 90. Since angle B and angle C are base angles of the same base, they are also congruent. So since the measure of angle B is equal to 90, therefore the measure of angle C is also 90. Are you all following? Okay, very good, my dear students. Example number 7. In an isosceles trapezoid ABCD, measure of angle A is equal to 3x plus 40, and the measure of angle D is equal to x plus 60. So the question here is we're going to find the measure of angle A and angle B. So look at in the figure. Remember that the base angles of an isosceles trapezoids are congruent. So our first step is we're going to find the value of x. So we have the base angles measure of angle A is equal to the measure of angle D. Then, let us substitute the value of its angles. So the measure of angle A is 3x plus 40 and the measure of angle D is x plus 60. Next step is combine like terms. Transpose positive x to the left side and that will become negative x, and transpose positive 40 to the right side and that will become negative 40. So next step is we're going to simplify the two equations. On the left equation, what is 3x minus x again? Okay, correct. That is 2x. And 60 minus 40, that is equal to 20. So the next step is you're going to divide it both sides by 2. So that will become x, and 20 divided by 2, that will become 10. Next, let us solve for the measure of angle A. Since we have the value of x, so measure angle A is equal to 3x plus 40. Let us substitute the value of x, which is 10. So we have 3 times 10, that is 30, plus 40 equals to 70. So the measure of angle A now is equal to 70. What do you think would be the measure of angle D? Okay, correct. The measure of angle D now is also 70. Since angle A and angle B are supplementary angles, then the measure of angle A plus the measure of angle B is equal to 180. So the measure of angle A is equal to 70 plus the measure of angle B is equal to 180. So bring down the measure of angle B and then transpose positive 70 to the right side, and that will become negative 70. So 180 minus 70, that is equal to 110. So the measure of angle B now is equal to 110. Since angle B and angle C are base angles of the same base, they are also congruent. Since the measure of angle B is equal to 110, therefore the measure of angle C is also equal to 110. Okay? Example number 8. We have WXYZ is an isosceles trapezoid with AB as an median. If base ZY is equal to 17 cm and base WX is equal to 11 cm, how long is AB? Remember that A median is equal to 1/2 of the sum of the two bases. So this is our solution. AB is equal to the sum of the base ZY and the base WX. Next, let us substitute the value of the base ZY and the base WX, which is 17 plus 11. So, what is 17 plus 11? Correct, that is 28. So, 1/2 times 28. What do you think is the half of 28? Correct, that is 14. So, AB is 14 centimeter. Therefore, the median AB is equal to 14 centimeter. Letter B. If base WX is equal to 10 centimeter and AB is equal to 25, find the length of base ZY. So here is the solution. AB is equal to 1/2 of the sum of ZY plus WX. Since ZY is still unknown, let us first substitute the value of AB and the base WX. We have 25 is equal to 1/2 of the sum of ZY plus 10. Next, in this equation, we have two ways. We can do the cross multiplication or just multiply it both sides. So we all know that 25, the denominator will always equal to 1. And here in the right side, ZY plus 10 over 2. So 2 times 25, that is 50. So in the right side, or in the right equation, just cancel the 2 and then bring down ZY plus 10. So we have the equation 50 is equal to ZY plus 10. Next, we can transpose the positive 10 to the left side. So that will become negative 10. So 50 minus 10, that is equal to 40. So the value of our ZY now is equal to 40. Here, we can use the symmetric property, which is if A is equal to B, then B is equal to A. That is a symmetric property. Therefore, ZY is equal to 40 centimeter. Example number 9. Given trapezoid mat with diagonal MT is equal to 7y minus 7 units and diagonal AH is equal to 4y plus 11 units. Find the value of y so that the mat is isosceles. So here is the solution. Consider the diagonal MT is equal to diagonal AH. So, let us substitute each value. We have 7y minus 7 is equal to 4y plus 11. The first thing that we're going to do is combine like terms. So, transpose positive 4y to the left side, that will become negative 4y. And transpose negative 7 to the right side, that will become positive 7. So, 7y minus 4y, that is correct, that is 3y. And 11 plus 7, that is equal to 18. Next step is you're going to divide it both sides by 3. So, cancel 3, bring down y, and then 18 divided by 3, that is equal to 6. So, the value of y here is equal to 6. So, when y is equal to 6, so let us substitute using the equation of diagonal MT. So, MT is equal to 7y minus 7. Let us substitute the value of y, which is 6. So, 7 times 6, that is 42, minus 7, okay, that is 35. So, the diagonal MT is equal to 35 units. Next is the diagonal AH is equal to the original equation, which is 4y plus 11. Then, same procedure, substitute the value of y, which is 6. So, 4 times 6, that is 24 plus 11. What is 24 plus 11? Okay, correct. That is 35 units also. Therefore, MAT or MATH is an isosceles trapezoid when y is equal to 6. Example number 10. Quadrilateral ABCD is a kite. As you can see in the figure, we have side DA is congruent to side AB, and side DC is congruent to side BC. In the given figure, we have two diagonals that bisect each others and form two right angles by intersecting. We have diagonal AC perpendicular to diagonal DB. So here is the question. What is the area of the kite ABCD if the diagonal AC is equal to 12 cm and diagonal DB is equal to 8 cm? Remember that the area of a kite is equal to 1/2 of the product of the lengths of the two diagonals. So here is the solution. Area of the kite is equal to the 1/2 of the two diagonals, which is the diagonal AC and diagonal DB. So we're going to substitute the value of diagonal AC and diagonal DB. So the value of diagonal AC is equal to 12 and diagonal of DB is equal to 8. Then let's get their product. So 12 times 8. Okay, so that is equal to 96 times 1/2. What is the half of 96? Okay, correct. That is 48 square centimeter. Therefore, the area of a kite ABCD is 48 square centimeter. Okay, try this one. Example number 10. A quadrilateral ABCD is a kite. Then, same, we have the side DA is congruent to side AB. And side DC is congruent to side BC. And we have two diagonals that bisect each others. We have diagonal AC that is perpendicular to diagonal DB. So the question here is we're going to find the area of the kite ABCD if diagonal AC is equal to 13 centimeter and the diagonal DB is equal to 7 centimeter. So same process, area of a kite is equal to 1/2 of the product of the lengths of the two diagonals. So let us substitute the value of diagonal AC and diagonal DB, which is 13 and 7. Then gets their product. So 13 times 7, okay, correct. That is 91. So what is the 1/2 of 91? Correct. 45.5 square centimeter. Therefore, the area of a kite ABCD is 45.5 square centimeter. Very good, my dear students. Example number 11. Quadrilateral ABCD is a kite. So here is the problem. If the area of kite ABCD is 40 square centimeter and diagonal DB is 10 centimeter long, how long is the other diagonal? As you can see in the given figure, the other diagonal refers to the diagonal AC, right? Okay. So, we're going to find the value of diagonal AC. So, same procedure. Here is the solution. So, same procedure for getting the area of a kite, 1/2 of the product of the lengths of the two diagonal. So, our two diagonal in the given figure is diagonal AC and diagonal DB. Since we have the given value of the ABCD or the area of a kite, which is equal to 40, and then the value of diagonal DB is 10 centimeter. Then just substitute it in this equation. So we have 40 is equal to 1/2, and then the unknown value of diagonal AC times the value of diagonal DB, which is 10. So here in this figure, bring down 40 is equal to, and then in this equation, we will divide it by 2. So AC times 10 divided by 2. In this equation, we have two ways. First one is we can do the cross multiplication or just multiply both sides by 2. Okay. So here, cancel the 2 2's in the right side. And then bring down AC times 10. Or that will become 10 AC. And then 40 times 2, that is equal to 80. Next is divide both sides by 10. Cancel the 10, bring down AC, and then 80 divided by 10, that is equal to 8. So the value of our diagonal AC is equal to 8 centimeter. Now, let us check if your answer is correct. So, using the formula of the area of a kite ABCD, which is 1/2 of the AC and DB, let us substitute. Since the diagonal AC is already given, just substitute it. So, the area of a kite ABCD, which is equal to 40, and then AC, the measure of AC is 8 centimeter. And then the diagonal of DB, that is equal to 10. So, using the PEMDAS, 8 times 10, that is equal to 80. Correct. And then 80 times 1/2. Or, what is the half of 80? Correct. That is 40. As you can see, in our checking, they are equal to each other. So for the last example, try this one, my dear students. We have a quadrilateral ABCD is a kite. And the measure of our area of a kite now is 75 square centimeter. And then the diagonal DB is now 10 centimeter long. And then we're going to find the measure of diagonal AC. So here is the solution. Same process for getting the area of a kite, which is equal to 1/2 of the product of the lengths of the two diagonals. Then substitute the value. So the area of a kite is equal to 75 is equal to 1/2 and times the unknown diagonal AC times 10. So we have here, we can divide the product of AC and 10 by 2. So in this situation, we can do the cross multiplication or just multiply both sides by 2. So in the right side, cancel the 2 2's. That will become 10 times AC, so that is 10 AC. And then 75 times 2, that is equal to 150. The next is divide both sides by 10. Cancel the 10 and then bring down AC. So 150 divided by 10, that is equal to 15. Therefore, diagonal AC measures 8 cm. Now, let us check if your answer is correct. So using the original equation of the area of a kite ABCD, substitute the value. So area of a kite ABCD, that is 75, is equal to 1/2, and then the value of AC now is 15, and the diagonal DB is 10. So 15 times 10, okay, that is 150. So 150 times 10, or what is the 1/2 of 150? Correct, 75. So here, your answer is correct. Let us recall, what is quadrilateral again? So quadrilateral has 4 sides, 4 angles, 4 vertices, and the sum of the measures of 4 angles is equal to 360 degrees. So, true or false? A trapezoid is a quadrilateral whose opposite sides are parallel. All parallelograms are quadrilaterals. Every trapezoid is a parallelogram. All trapezoids are parallelograms. Kite, the perpendicular bisector of at least one diagonal is the other diagonal. So how many scores did you get? Okay, very good, my dear students. Let us try to solve this. Given we have the measure of angle A is equal to 3x plus 9, the measure of angle C is equal to 3x, the measure of angle B is equal to 5x plus 20, and the measure of angle D is equal to 2x plus 6. So let us now find the measure of angle D. Remember that the sum of all angles of a parallelogram is always equal to 360 degrees. So in order to get the perimeter, let us add or the sum of all angles. So we have 3x plus 9 plus 5x plus 20 plus 3x plus 2x plus 6 is equal to 360. Is combined like terms. So we're going to add those value of the x. So we have the 3x plus 5x plus 3x and plus 2x. So that is equal to 13x. Then 9 plus 20 plus 6, that is equal to 35. Then transpose positive 35 to the right side. So that will become negative 35. Then let us simplify. Bring down 13x is equal to 36 minus 35, that is equal to 325. Then 325 divided by 13, that is equal to 25. So the value of our x now is equal to 25. Since we have the value of x, which is 25, next is we're going to substitute the value of x using the original equation of the measure of angle D. So we have the measure of angle D is equal to 2x plus 6, then substitute. So that is 25 times 2, that is equal to 50, plus 6 equals to 56 degrees. So that is the measure of our angle D. Are you guys ready? Okay, that's great. Now, you can answer your activity in your module. Good luck! Again, I'm your virtual teacher, Miss Emily Sungkuan.